let's work through this same process with this polynomial function to try to find its real zeros. Remember that the number of real zeros at the most is the same as the degree of the polynomial function. This is a third degree polynomial function. Highest power of the variable is 3. So at most, that polynomial function would have 3 real zeros. It may not have 3 real zeros. Some of the zeros could be complex numbers. But at the most, if it had real zeros, at the most it could have would be 3. According to Descartes' rule of signs, if we count the number of changes in the signs of the coefficients of f of x, that'll tell us how many positive real zeros we would have. This is a plus 4 to a minus 4, that's one change, and then it stays minus, so only one change in the coefficients, the signs of the coefficients of f of x, so that tells us there would be one positive real zero. Then we look at f of minus x and count the number of changes there. Minus to minus is no change. Minus to plus is one change. Plus to minus is a second change. So Descartes would tell us that we will have 2 or an even number less than 2, which an even number less than 2 is 0. So Descartes would say we'll have either 2 or 0 negative real roots. Now, remember the rational roots theorem. Says that the rational zeros theorem says that if we have rational roots, if we have rational zeros, they have to come from the rational numbers, the fractions we can form by taking the factors of the constant and putting them over the factors, oops, pointing at the wrong one, factors of the constant, putting them over the factors of the coefficient of the first power term. Excuse me, the third power term, the highest power in this case. So to form our p's, because we're going to mind our p's and q's, the p's, again, come from here. The q's come from here. So the p's are plus or minus 1, plus or minus 2, and the q values are plus or minus 1, plus or minus 2, plus or minus 4. Those would be the factors of 4, wouldn't they? And so now I need to form all the fractions, p over q, that can come from taking one of the p values, putting it over all of the q values, and doing that for every p value. So 1 over 1 is going to give me plus or minus 1. 1 over 2 is going to give me plus or minus 1/2. Ooh, fractions. 1 over 4 is going to give me plus or minus 1/4. 2 over 1 is plus or minus 2. 2 over 2 is 1, which we've already listed. And 2 over 4 is 2/4, which is 1/2, which we've already listed. So if, remember, that's the big word there, if there are rational zeros for this polynomial function, they would have to come from that set of rational numbers. And Descartes tells us there'll either be 2 negatives or no negatives, and there'll be 1 positive. Well, I'm not real thrilled about messing with the fractions, so let's try one of the numbers. And we will test again to see whether or not we have a real zero by using synthetic division. For our synthetic division test, then, let's test 1. So if 1 is the 0, if 1 is the root, then really what we're doing is we're trying to take f of x and divide it by x minus 1 if I'm going to test whether or not positive 1 is a root. So I'm testing whether or not positive 1 is a root. So I put positive 1 outside the synthetic division sign. I put the coefficients inside. That's 4, negative 7, negative 2. And remember, if one of those terms was missing, you'd have to put a placeholder there of 0. So again, let's go through the synthetic division process. We bring that coefficient down unchanged. And then we start a process of multiply, 1 times 4 is 4, carry, add. Negative 4 plus 4 is 0. Multiply, 1 times 0 is 0. Carry that 0 over here, add. Negative 7 plus 0 is negative 7. Multiply, 1 times negative 7 is negative 7. Carry the negative 7, add. Negative 2 added to negative 7 is negative 9. This is the remainder entry. Remember, the only way that this division worked is if the remainder is 0. And having a remainder there of 0 tells us that we had a real 0. We had a real root. So we don't have a real 0. 1 is not a value that if we put it in for x, it's going to make the function 0. So we can eliminate 1.